Okay, so I wasn't sure if that came across as clearly as possible in that lesson. Again, sorry, we normally have quite a lot more time than this to establish what we need to do. I'm hoping I can help this become an easy lesson, not a hard lesson. Usually people find this graphing to be one of their better topics. So let's see if we can make it land just a little bit better. So if you need a little extra help, here's a couple of quick examples. What you can see is I literally just took the homework assignment and I just changed a couple of numbers so that we have something a little extra to go on. So again, the way we start every problem is you start by looking at the vertical shift, and that's going to be right here, the middle of our graph. Some people call it the midline, some people call equilibrium. Our amplitude is 2, so that's going to be go up 2 and down 2 from where the -1 vertical shift was. In this case, nothing is directly attached to X, which means my phase shift would actually slide not to the right, but to the left pi/2. Okay, so that kind of tells me something. Now, we did mention that positive sine waves always start at the middle and they end at the middle. And they kind of have this kind of pattern where they start at the middle, they go up, they come down, they get all the way to the bottom. And if I'm not being clear, this should hit the top of the box and the bottom of the box. If that's not 100% clear, some people like to put the midline in here so they can see it. It just looks a little nicer, and you can do that. Now, again, the period is always 2 pi divided by the number in front of here. But in this case, there's no number there, so it's a 1. So what I'm going to do is I'm going to create a common denominator of 2. So I'm going to multiply the top and bottom by 2. So that would be 4 pi/2. So if I start here and I move to the right, I started at -1 and I moved to the right 4 pi/2, I landed at 3 pi/2. Now, to find the middle of those, what I personally do is if I can just see it, I do. And if I don't just see it, I just add them. When I take -1 and +3, add them together, I get 2 pi/2. And if I cut 2 pi/2 in half, I get 1 pi/2. Right in the middle of -1 and +1 would be 0 pi/2. And right in the middle of these would be 2 pi/2. Now, I should reduce these. In fact, I'll reduce this to pi right here. But really, I usually leave them without reduction until I'm done with the problem because often those common denominators are very helpful. Now, in the second problem, I went ahead and I made it a positive cosine wave. Now, again, positive cosine waves start at the top and end at the top. We kind of go like this. So it kind of cruises out and dips down like a roller coaster. And then it comes back up and then it tips back over like this. So that's what a pretty nice looking cosine wave looks like. Again, vertical shift of 1, amplitude of 8. So I'm going to go up 8 and down 8. So keep in mind this is plus a and minus a every single time. Now, this is one of those things that I warn you guys about. Never let anything be attached directly to X. So if I factor that 3, factor is divide. So if I divide it, I get pi/36. That's a little unpleasant, but we'll see what happens. So this thing got kicked to the right. Notice this one is to the left. This one is to the right. And my period is 2 pi/b, which is 3. Now, I'd like a common denominator, but I notice that if I multiply the top and bottom by 12, I would have that common denominator. So if I started at 1 and I move to the right 24, I get to 25. Now, if I add these together, I would get 26. And if I cut 26 in half, I get 13. That's pretty good. It's not too bad. So right now, you got 1 pi/6, 1 plus 25 is 26, cut in half 13. Now, when we do these, 1 plus 13 is 14, cut 14 in half, and I get 7. Add these together, I get 38, and if I cut 38 in half, I get 19 pi/36. Now, one thing that should happen because of just you're modeling the unit circle, notice from here to here is 6 pi/36, and then another 6, and another 6, and another 6, and it worked perfectly. Now, my plan was to look at I know a lot of students very much struggle with what the normal graph paper is, and most math teachers will never show you this box method. They only hand you this and say, hey, graph it on that. So what we're going to do is we're going to try to graph 2 sine x plus pi over 2 plus, minus 1 on this graph paper. So the first thing I do is I kind of look for where minus 1 is. That would be right here. So I'm just going to highlight because that is the midline, okay? So I know my graph is going to be centered around that. I know my amplitude is 2, so I know that the top of my wave is going to be here and the bottom of my wave is going to be here. That's just the vertical lines that I put up here. And it says that if I go to negative pi over 2, I should have had negative 1. So that was right here. So that I called A, which would have been this value right here. B at 0, we were at 1. So 0, comma 1. Here we go. There's B. By the time I reached pi over 2, right here, I was at negative 1. Now you can start seeing the pattern. It goes over 2 and up, over 2 and down. So then at pi, it's at minus 3. That's right here. But then what do you see? 1, 2, and it goes down. And then 1, 2, and it goes back up. And 1, 2, and it goes back up. And so we can kind of repeat this process for a while because it is supposed to be a periodic function. So it's supposed to show that it keeps doing this forevermore in both directions. Okay, so just a couple of a little bit harder problems, and then I will conclude this. I didn't want this video to be very long. But again, if we start here at 10, my vertical shift. Again, my amplitude is not negative, but positive 5. So I'm going to go as high as 15 and as low as positive 5. Notice we started here at 10. We went up 5 and down 5. Now, the value is already factored out, so I don't need to worry about that. So my phase shift is plain old pi over 4, and my period is 2 pi divided by 1/3, which is 6 pi. Ooh, that's kind of weird. Remember, flip-flop and multiply. So if I made a common denominator of 4s, this would be 24 pi over 4. So I started at 1, and I moved to the right 24. That lands at 25. Right in the middle of 1 and 25. Actually, this is kind of similar to a previous problem. Those add up to 26, so 13. 1 and 13 add up to 14, so cut that in half, 7. Notice again it went up 6, went up 6. It should go up 6 again, and up 6 again, so that looks good. And then, of course, a negative cosine wave starts at the bottom, ends at the bottom, and crosses the midline on its way up. So this graph kind of looks like this. And I'm trying to show you something about the curvature that notice it's coming and it's swooping up. Here it's kind of swooping down. And so I'm trying to give you the idea that it's not just like a parabola kind of shape. Now, the very last one that I had on purpose, I did not factor something out for this one. So when I pull the 5 out, remember factoring is dividing. So that means when I divided by 5, that's going to be my phase shift to the left, pi over 10. Now I also did this because with a 7 and a 7, that means when I go up 7, it's actually going to force it down to the bottom to be 0, which is kind of interesting. And again, period of 2 pi over 5, also known as 4 pi over 10, common denominators. Start at -1, move over 4, that lands at 3. Right in the middle of -1 and +3 is actually just +1. That's going to put 0 here. And when I add those together, it would be 2 pi over 10, also known as pi over 5. So -1, 0, 1, 2, and 3 pi over 10s. And a negative sine wave starts at the middle and ends at the middle, but instead of going up, it goes down at first. So we're going to swoop down, come back up here, and try to hit that box. Not like I keep doing, I just keep showing you bad examples. And there we go. So those are a couple of quick examples of the box method, which I think is a little bit easier than graphing them on standard graph paper, but it does represent the same thing. Hopefully that's helpful. I'll see you soon. Bye-bye.